start with Ruo Ando.
Hello everyone. I'm really excited to talk here. So thank you for listening to me. And in this presentation, I'm going to talk about weird application using multithreading for analyzing huge PCAP file. This is a tool which take full advantage of multi-core processor and achieve high performance improvement. Actually, is there anyone in this room that thinks that Wireshark is a little bit slow? No? The design goal of this tool is a kind of multi-threaded Wireshark with automated deduction. So I guess multithreading can be one of the new frontier for packet inspection. Okay. Sorry. My name is Ruo Ando. I'm working in a governmental organization, so I'm not weird. So my talk is divided 4 parts. At first, I would like to talk about the current catastrophic situation of traffic analysis. The funny thing here is that we have too many packets to be inspected. However, for the problem to have the solution, we have more packets. This is kind of really helpless situation. I'll tell you what later. And the second one is the main part. When you build a tool for analyzing huge PCAP file using massive threads, you have some selections on how to convert code into a concurrent version. And the selection of features and containers and synchronization mechanisms such as mutex, lock-free, and something like that. And the third part is a demo and experimental result. Simply stated, speed up is a ratio of parallel execution time to serial execution time. So I'll show you the comparison. Then let me conclude this talk. This slide shows the catastrophic situation. As everyone of audience already know, internet traffic is increasing at exponential rate. However, there are too few professionals. Sorry. Sorry. So I'm so excited to forget what's going to. Thank you. Huge traffic imposes a great burden on security researchers and analysts. But traffic explosion is not similar to the hacking or exploit, because hacking and exploit is impulsive and will be finished within several minutes. But this is not the case of traffic explosion. Unfortunately, traffic explosion keeps exploding like an accident of nuclear power plant. So, in my case, in my laboratory, I have 200 to 300 log files to be stored in the server to be inspected. Well, during this 20 minutes presentation, 3 to 5 gigabyte file is stored to be inspected. This is really helpful situation for me. So the automation is really important for me and everyone of audience. But for my experience, open source data mining tool doesn't work in many cases because in the world of advertisement and marketing, commercial tool is not going to find people trying to hide his activities. And to make things more worse, open source data mining tool simply ignore people trying to hide and assume benign behavior is a part of everyone else. So I would like to emphasize that packet dump is a last resort. PCAP file is rare and hard to find source to be trusted. And machine learning, this slide, 1 million versus 1 trillion. Machine learning has table property. I tell you what, if machine learning doesn't work on the data set comprising 1 million training data set, what is needed? What is needed is much more bigger set. This is unexpected because if the machine learning failed in the data set comprising on 1 million training data set, the intuitive conclusion is that it doesn't work at all. But according to this paper, all we need is much more bigger packets. So the situation is very curious, isn't it? So Asura has 4 features. At first, Asura should be run on commodity workstation and laptops. It can run with reasonable computing resources. Because GPU and clustering system such as Spark is still expensive and high cost and sometimes bulky. And more importantly, Asura uses POSIX pthread, which is really old programming style. When writing a program, choosing appropriate level of abstraction is really important. Usually, hardly anyone misses the old programming method, except hackers. What we are copying here is a real-world packet stream, which is huge, not nice, not organized in regular pattern, and unfortunately unpredictable. So flexibility is important. Like you use assembly language for analyzing malware binaries. So raw threads and MPI expose the control of parallel computing at the lowest level. But at the lowest level, we don't have libraries, containers, and schedulers. So you have to implement these utilities in full scratch by yourselves, like the era of 1980s or 1990s. I guess this field can be one of the new frontier for packet inspection. As a result, Asura is compact but powerful. Actually, Asura has about 2,000 lines of code, but can process about 75 million packets in 200 to 400 minutes. Okay. This is intuitively simple. Asura takes 2 steps. Reduction using task decomposition and clustering using data decomposition. As you know, reduction takes a collection of data and reduce it to single scalar value. And the clustering is a task of grouping data in the same group in such a way that data in the same group is more similar than to those in other groups. And the important thing here is reduction passes container to clustering. The container is a really important key in this 2-stage processing. Container is a class template of C++, and the future selection are almost all anomaly detection of packet based on futures. There are many research efforts, and futures could be many. But the important thing here is to find a proper representation for reducing massive PCAP file. We use this representation in the middle of this slide, key value, and we use 2 structures. This is a little bit complicated. Please see the source code in the detail. And let me talk more about containers. Containers is a really important point for multithreading. You have 3 options. First one is STL. STL is old, basic, and regular programming style. But STL is not concurrent friendly, so it is a standard practice to wrap up a lock around STL to make them safe for concurrent access. And the second one, 10 minutes left. Second one is Intel TBB. It's an excellent library, but Intel TBB provides highly concurrent container. But the highly concurrent container is sometimes high cost. It takes longer time. And I guess this one is mainly for scientific computation. So unfortunately, what everyone here is doing is not like science computation. So the data is not well organized and unpredictable. So in this case, TBB is not suitable, I guess. And the third one is the emerging technology of Thrust. Thrust is a C++ template library for GPU. By using Thrust, you can write a code to perform reduce, scan, and something like that, accelerated by GPU. But unfortunately, as far as I know, there's no plan to implement the hash table, map, and associated container in GPU. So I guess it'll be time to be common for packet inspection. I guess this could be a future work. And this slide is the main architecture of Asura. If you have a case when the computation time on individual PCAP file is variable and unpredictable, you would be better served by task decomposition. Specifically, if you have a case the amount of computation time will vary. Dynamic scheduler will be best. And here, as with dynamic scheduler of task decomposition, load balancing is important to take into consideration. You have to implement scheduler by yourself. So please see the upper side of this slide. This is a shared container, which is queue. The dynamic scheduler involves setting up the shared container, which holds data and allows threads to pull out tasks when the previous task is completed. So you should protect shared container so that the thread can be assigned correctly and task should not lost through some corruption of shared container. Okay, let me show about experimental result. To put it simply, the speed up here is the ratio of parallel computing time to sequential computing time. And scalability. So what is scalability? I think scalability is a measure of how much speed up the program gets as you add more and more core and thread. I guess that this kernel tuning is proper, but I don't know exactly, but with proper tuning of Linux kernel, Asura can 75 million packets with 500 threads in about 287 minutes. To tell the truth, there are some rooms to be improved. Because the size of shared container is not proper. Lock intention and context switching occurred too much. So, but I guess it's reasonable that Asura can process more than 7 million packets in several hours. And I would like to skip the attack detected in detail because some issues of public data set. So instead, let me show you a demo, 1 minute demo. First of all, the binary is compiled according to the configuration of number of threads. And reduction step 1. So this demo is too fast, so I cannot illustrate. Reduction step 2. And building binaries for clustering. Clustering has 5 to 7 dimensions. And the data is truncated for this demo, which is too short. So, do you know what's going on? Sorry, I don't know what's going on. Because machine learning is too fast. The machine learning relies on so huge data set and processing speed is so fast. So machine learning might solve problem. We cannot expect it to solve in a way such that we don't fully understand. So the demo is too fast, so I cannot talk about it. Okay. So let me conclude this talk. I have talked about a little bit weird application, which is called Asura, using multithreading. For coping with real-world PCAP stream, which is huge, not nice, and sometimes evil, flexibility is needed. Just like you should use assembly language for malware binaries. But using raw thread and MPI takes advantages of retrieve full performance of multi-core processors. And pthread can expose the control of parallel computing at the lowest level. But unfortunately or not, we should implement everything. Libraries, containers, schedulers, which is really exciting for me. And as a result, they offer maximum flexibility. So as a result, Asura is compact but powerful. Asura has thousands of code and can process more than 70 million packets in 200 to 5 million. 200 to 5 minutes. For future work, Asura must be speeded up because there's room to improve. Configure the size of containers and applying TBB and GPU. And I really recommend this multithreading, applying multithreading for packet inspection. It's really exciting. This can be one of the new frontiers for packet inspection. So, thank you everyone. That's all. Thank you for listening.